Sir, should we carry out hydrostatic test before carrying out the tap connection in the pipeline?
Hydrostatic test is carried out by your supplier. No?
I understand, sir. But should we carry out before connecting the PPR pipe, which are carried to tap connection?
No. For this distribution pipe also,
Yeah.
you can collect or procure the sample on random basis, and you have to do all these tests, particularly for hydrostatic test.
No, I
From
understand
this
that.
test,
Yeah.
you can identify whether is a weak point is there or not.
But should we do it before connecting the PPR pipe? That means which leads
Obviously you should do it. Otherwise, how can you assure that the pipe material has been supplied good quality or bad quality?
But our system should withstand the pressure along with the tap connection. Ultimately, so why should we do before tap connection? My question is that. Because our system is to run with the all tap connection and that.
Tap connections.
Yeah.
It needs a network, sir, network.
Network,
After
yeah.
forming the pipeline network. Yeah.
After forming the pipeline network, it will be very difficult for you to carry
You
out
cannot-
this test.
But you cannot take out the pipe
and so
do the testing.
and these are standard test and accelerated test, and that is why these tests are mentioned in the standard before laying up,
Starting the service.
before laying up, to ensure the product quality during service.
No, I understand that, sir, but our system has to run along with all the tap connection and others. So it should carry the pressure at that time only. My question.
Right. So when the standard is formulated or it is specified, these tests are specified in the standard, keeping in mind all these requirements, taking into consideration all these requirements. So once these tests are passed, that means it satisfies your requirements as per the BIS standard, and these tests are passed means it will perform okay during the service life. What is the purpose of hydrostatic field testing? To assess the installed structural integrity of the pipeline.
This is a very important point.
Try to reveal the occurrence of faults or defects in the pipe laying procedures as exemplified by damaged pipe or fusion joints non-conforming to the qualified fusion procedures. Now, during the laying up and jointing, if there is any minor fault, so that may show up in the failure of the pipes, premature failure of the pipes. Try to reveal the occurrence of faults in the assembly procedures for pipeline components also, as exemplified by tapping bands or saddles, flying sets or mechanical joint assembly. This is also to validate that the pipeline will sustain an acceptable level of overpressure slightly greater than its design pressure without leakage. Now, the concept behind hydrotesting is to strain the pipes, fittings and accessories. To strain the pipes means by putting the pressure, by putting the induced hoop stress, we put pressure in those areas to ascertain that there will not be any failure during the service life or during the transportation of the pressurized fluids. It may be water or it may be slurry or it may be any other solvent. During the service life, that should not show up that should not lead to failure of the product. So any defect from manufacturing is typically forced by stress intensification, which I was mentioning earlier, that if there is any defect during manufacturing, so that shows up, or that point acts as the weaker point, or it is known as the stress concentration point, where the stress is concentrated, and that leads to premature failure. Any remaining defects are considered subcritical within a tolerable flaw size. Hydros testing provides the normal level of assurance for leak integrity and the absence of major flaws. Generally speaking, the higher is the ratio of test pressure to actual operating pressure, the more effective is the test within the material stress limits. That means, if the pipe is tested at a higher pressure and the actual pressure during the service life is much lower compared to that, then the product quality is more assured during the service life. The chances of failure will be minimum. These are our grades. These three grades we produce for three applications: P63, P80 and P100. The grades are P5200, P5100 and P5300. The MFI and density is mentioned. These grades are very much appreciated by the manufacturers and performing very well in the respective areas of application. This I have already shown you. This also I have already shown you. This also I have shown you. These are the advantages which I have mentioned so many times during the entire session. This is a very lightweight and flexible pipe, easier to handle, long lengths can be laid in short time, HDPE pipe saves and conserves water compared to metal pipes, the chances of leakage will be minimum, this is commonly joined by heat fusion. Excellent hydraulic characteristics, extremely smooth inner surface, non-corrosive. It can, being a flexible pipe, it has got, this is softer and it has got certain elongation properties for which it can adjust its shape if there is any pressure surges during the transportation of the liquid during the service life.
There is a provision of socket joint also.
There is a provision of socket joints also. Yes. But normally it is not done.
The socket joints are put during repairing of any joints.
If they go, those are mostly for repair joints there.
Time taking or what?
It is time
It
taking.
is time taking, time
Much
taking.
costlier than the.
And the expensive, sir. It is expensive.
It is much safer also.
The abrasion resistance of the pipes are very high. Abrasion resistance is very high, and that is why the energy requirement is very low. And as a result, you may consider that the carbon footprint will be lower. No corrosion. It is highly resistant to corrosive chemicals and corrosive solvents. And there will be no minimum chances of, or almost no negligible chance of biological growth or root intrusion in the pipes. This is the type of lot certificate that we provide to all the customers to which we have supplied our grades. This is for P100 and this is for P80 grade. Thank you for your kind attention. If there is any question from your side, I will try to answer. And if I cannot answer right now, if it is not available with me or it is not known to me, I will definitely come clarify it later. Definitely.
So, as Mr. Maiti was mentioning, the total piping system, the success of the piping system depends on many factors. One is the pipe quality, another one is the mentioned, as you mentioned, the jointing, and third is the fittings, whatever fittings you are using, and fourth is the workmanship, who are laying the pipe. So, if all these factors are placed in good shape, then only you will get the successful piping system. And the workmanship training also can be provided through this machineries, or even the pipe supplier, they can arrange the workmanship training from all the plumbers. Because this butt joint is very easy. In 1 hour, somebody can, one person can, how many joints
One person can perform, sir. One person can perform. It's like about in 8 hours, if like for a smaller pipe, like 63 mm or so. They can perform like about 20-25 joints.
depending on the thickness per hour.
Per 8 hours.
It takes 6 to 7 minutes.
So depending on the diameter as well as thickness.
It takes time to get the plate heat.
If the thickness is higher, then it will take much higher
Plate
time.
heating is only the initial time, sir. Initial time, it takes 15-20 minutes for the
No,
initial.
jointing problem is the maximum problem.
Hmm?
Jointing problem is the major problem.
Launching.
Jointing
Jointing is the main issue everywhere.
There is no sufficient knowledge.
Yes, sir.
Yeah, that's why we have doing this workshop also. Okay, now Mr. Purushottam will be demonstrating how the proper jointing to be done and what are the parameters which are most important for every joints to be considered during the jointing process.
Thank you once again for your kind attention.
I'm happy to be here today. I thank the entire PhD and JJM team here. I thanks for giving this opportunity to explain about the bud fusion and plastic jointing process. We are Leicester Technologies India Private Limited. We are a Switzerland-based company, Switzerland-based MNC company. This Leicester India is completely owned by Leicester Switzerland Group. We are into plastic welding technology, and we have everything for plastic welding, right from flooring to roofing, furniture, automobile, And for every other plastic welding application, we have machineries. In India, Leicester and Ripco is an Italian company. In India, Leicester and Ripco has a strategic collaboration for selling this plastic pipe welding products. Our relationship started from 2005, and before that, since early 90s, Leicester Ripco has a presence in India through major agencies, government agencies. Coming to Ripco is a pioneer in plastic pipe welding technology. This company has more than 4 decades of expertise in plastic pipe welding. We have been supplying this HDPE, butt fusion, electrofusion, jointing machines to various industries, right from potable water, gas networks, industrial pipeline desalination, etc. So firstly, today our main agenda is to see the PE pipe joint. PE is nothing but the polyethylene. Earlier, the Haldia team has explained completely about polyethylene and their properties and the resin characteristics and the raw material characteristics and everything. Thanks for this detailed explanation. We'll just quickly see what is the main advantages of using PE for potable water networks. This starts from these pipes are being manufactured in wide diameter ranges, starting from 20 mm to up to 2,800 mm. But right now in India, it is maximum is 2 meters in diameter. These pipes have great mechanical properties which can withstand in the field conditions. This also helps laying it faster in the field. The projects can be completed very much within the timeline. As we know, the Jal Jeevan Mission projects are being framed into a shorter time duration. HDPE pipe is very much feasible to complete the projects. And moreover, these pipes have a higher life expectancy because it is corrosion free and it has other mechanical properties compared to metal pipelines. HDPE or any PE or these PE pipes basically comes under the polyolefin group, PE and both PP, polyethylene and polypropylene. PE pipes can only be joined with the thermal jointing technique. Thermal jointing is the only way to join any polyethylene pipe. Either it is HDPE, that is high density polyethylene, or medium density or low density. In water pipeline, majorly used pipeline is high density polyethylene, which usually comes in black in color with a blue stripe. That is, as earlier team explained, this blue stripe indicates water pipeline. Similarly, gas pipelines has a yellow stripe. So the first fusion process for polyethylene is butt fusion. Butt fusion, as the name itself means, butting the two faces of the pipes, as like this. So this is the best jointing technique. So that what happens is, this is as good as a single extruded pipe. Suppose we are jointing 6 meter length of pipes. This becomes a single 12 meter pipe. 6 meter plus 6 meter, that becomes a single 12 meter pipe. This is actually seamless pipe, seamless joint. This becomes a seamless joint. Once we remove it forms a bead. I will show you during the demonstration. It forms a bead, but when we cut open the bead, this becomes as good as a single extruded pipe. And the second technique is called electrofusion. As we see here, the two pipes are joined with the help of a coupler. This coupler has inbuilt electrical coil. I'll just show you the coupler.
Can you make a joint practically?
Yes, definitely, sir. This is the coupler, and this has got electrical coil inside the inner periphery of the coupler, and there are 2 leads taken out here. So we will apply a current across this coil, so that what happens is when we apply the current, this coil gets heated up. Once the coil gets heated up, the ID of the coupler and the OD of the pipeline gets heated, and this forms a homogeneous joint. For that, this coupler has to be of the same material of the pipe. Means, suppose we are using HDPE 80 grade, then this coupler also has to be HDPE 80. This has been printed here, PE 80, and of SDR 11, diameter 110.
So it is 110.
Yes, sir, 110.
How much cost it is?
Sir, cost, we don't manufacture these couplers. There are coupler manufacturers. I'll let you know about the coupler manufacturers. These are expensive, sir. These are expensive.
But if you want, we can give you the contact details of this, all the electrofusion joints.
The main difference between these 2 joints is the butt fusion process. The initial capital for the machinery is more, but every joint is free because we use the same material. We heat the same pipe and joint it together. But whereas in the electrofusion joint, every joint requires this coupler. This coupler is an additional cost for every joint. So basically, coupler joint is preferred for lower diameters. Lower diameters, which is less than 90 mm, so that the pipe comes in coils of 200 meters. So the number of couplers used in the network will be lesser. Yes. For lower diameters less than 90 mm, the pipe comes in coil form, so that like 200 meter or 150 meter coils, so that the number of couplers will be required will be less for the jointing.
Less number of joints. Because you will get a single pipe length of 150 meters.
That is obvious because it will be of less than 75
What he is suggesting, so in that case, what diameter pipe?
This can be
This kind of
This joints can be preferred as the cost will come down. But the best way is always butt fusion. So let's see butt fusion in detail. This butt fusion machines are manufactured to standard ISO 12176. This standard governs the manufacturing and the design of this butt fusion machineries. This standard is globally used. Not only in India, it is globally used. And the welding procedures follows to TVS 207. And ISO 21307 is also a standard being used by for the welding procedures and welding standards, welding parameters. The main application of butt fusion is in pressure pipelines and drainage or sewage lines. When we talk about butt fusion, there will be a question. There is a manual machine which can be used. People used to ask, but manual machines are not preferred for pressure pipelines. Pressure pipelines needs to be joined with pressure because this machinery has 3 main parameters. First, we will see what are the components in the setup, butt fusion setup. The butt fusion setup has got a machine body. This is the machine body which is placed over the table. And we have a heating plate. This is that heating plate. And we have a milling cutter. This cutter has blades on both the sides to face off the pipe. And we have the hydraulic power pack. This hydraulic power pack which supplies the required pressure to the system to join the pipes. welding parameters, there are 4 important parameters which is required to make a butt fusion joint. The first and very most important parameter is heating temperature. That directly depends upon the melt flow ratio, MFR of the pipe or the raw material used to manufacture the pipe. Then it is the pressure to make the joints and the time of various phases of the welding. There are 5 phases in the welding, I just explained, and each phase has a timeline and the bead dimension. I will explain to you what is bead and what is the bead dimension. So, based on the working conditions, butt fusion gets affected. Butt fusion joints work between -5 degree and up to 45 degree. And beyond this temperature or lesser than this temperature, there are certain risks involved in the process. I will just explain to you. For higher temperature, what will happen is the pipe will slip inside the clamping as like this for higher temperature. So that we will not be able to make a proper joint. So if you ask me whether if it is for higher temperature or lower temperature than this, if this fusion is not possible, there are possibilities there, but that requires special machineries. Not with the regular fusion machineries, it is not possible. For lower temperature, what will happen is the pipe will tend to crack near the heat zone. That is where we are going to heat. At the face, near the face, it will tend to crack. And the second risk involved is pipe shape. As explained by the team, the ovality of the pipe will affect the joint. So what will happen is there will be a weakness in the joint, so that there will be unwelded areas in the so what will happen is there will be leakage. The third risk is pipe alignment. So pipe has to be aligned to the same axis. Both the pipe being joined should be in the same central axis. If it is not properly aligned, then again there will be unwelded areas and there will be unnecessary mechanical tension in the joint area.
Working temperature is the ambient temperature?
Yes, sir. Ambient temperature at the site, jointing site. And pipe ends cleaning is very important in any fusion process, both electrofusion and butt fusion. This pipe ends has to be cleaned properly before jointing. This joint preparation is very important. This has to be properly scraped, cleaned, and the faces has to be uniform. For electrofusion, it is recommended to clean it with isopropyl alcohol, IPA solution. So, I explained about the welding process. So, these are all the basic inputs, and this is the welding table. The diameter D or DN explained in the standard is an important parameter. That is the input for selecting the jointing parameters. And the next parameter is SDR, standard dimensional ratio. SDR is the ratio between the diameter OD of the pipe and the thickness, nominal diameter to nominal thickness of the pipe. So based on this parameter, we can arrive at the temperature for jointing. Temperature, then we get the pressure, and we get the time taken, and we get the bead thickness. Where in the column 1, we have the pressure, jointing pressure, and in the same column we have a parameter called A. A is nothing but the bead thickness. Bead is the rolling over of pipes when we join. And various times during the various phases. I will explain the welding phases. So here we have the building chart. The first phase is called the preheating phase or bead up phase. So during this phase, what happens is we preheat the faces of the pipe faces. Both the faces of the pipes is being preheated at a temperature specified in the chart with the pressure P1 plus Pt. P1 is the pressure from the welding chart. P1 is the pressure from the welding chart, and Pt is the drag pressure. That is the pressure required to pull the pipeline, entire pipeline. Suppose we will at field we will be jointing single length of a pipe of 6 meter or maybe a 5 length of pipes of 30 meter also. We may have to pull 30 meter also, or we may have to pull 6 meter, like that. So this Pt is a changing parameter. That is not a constant. That varies based on the field condition. So Pt is the drag pressure. We need to measure that with the machine. Pt is the pressure at which the carriage starts moving. This machine has a movable and a fixed carriage. The movable carriage moves with the help of a hydraulic pressure, and the pressure at which the carriage starts moving is called Pt, that is drag pressure. So the second phase, during the heating, once we achieve the desired bead thickness of 2.5 mm as mentioned in the column 1, we will drop the pressure to a value equal to or less than drag pressure. We are going to do that. Then we will maintain up to time T2. Once T2, the time T2 is completed, what we are, as I explained, the first phase, we are closing, and you may see a bead forms, and we reduce the pressure. And in the third phase, we remove the heating plate. And in the fourth phase, we close the pipe. And in the fifth phase, the welding happens, and then you may see the bead formed in the center. The cross section of the bead also. This is how a cut section of a butt fusion joint will look like. You will have an internal bead and external bead also, and on both the pipes there will be a bead. So it is twin bead inside internally and externally there will be. If you cut open this bead, this pipe is as good as a single extruded pipe. The both pipes will be look like a single extruded pipe. So this is all about butt fusion. I hope the process is clear.
Temperature, but like preheating time, there's some temperature is defined.
Yes, it is defined in the chart, sir.
How much?
Yeah, I just show you. Yes, sir. So suppose in this chart, the diameter is 225, the temperature is 205. For PE pipes, it is mostly 190 plus, just above. This jointing pressure is just above the MFR temperature.
This is 205
centigrade.
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 MFI, like what is the melting temperature of the
Melting temperature is 190, sir.
for the
190 for
HDPE?
PE. Polyethylene. 190 for PE, and this is just above 190. And it will be up to 230, sir. Up to 230.
And the time lag from T1 to T5, how much time will take?
That depends on the diameter and thickness, sir. That varies with the diameter and thickness.
For 110.
So suppose for
T1 to
225, the total time taken will be like we have 205 seconds for the initial welding, and we have a cooling time of 26 minutes. So it will be somewhere around 30 minutes for 225 diameter joint. For 110, it will be like half the time.
For 1
20 minutes it will be.
average
Yes.
20 to
20 minutes. Per joint it will be 15 to 20 minutes.
the standard procedure.
This has a chance, sir.
There is one point.
Yes, sir.
These pipes and joints are not time tested in our state because this is first time we are using HDPE pipes.
Okay.
During your career, do you receive any complaint of leakage or leakages in this?
Because
How long you are in this business?
5 years, sir. 5 years now.
5
Well,
years
like,
is very short time.
for me it is not
Because
answer, but
these are not time tested.
Literature, what the literature say, like, it's robust and nothing.
it's robust, sir.
Literature will say a lot of things. But
Sir,
that's
I
all.
No, sir, for the jointing also there is standard.
Yes,
This is not IS standard, ISO standard.
yes, international standards.
International standard is there. If you want, I can share with you.
My point is that actually our observation is that we are basically doing in a very in a huge rate, like.
Correct.
What you mean to say that like suppose it's an executive like is handling more than 500 skills at one time. So in that respect, like to do with the operating procedure, to maintain the operating procedure is not easy because the works have been done in the rural level. So the skillness also depends, no? You cannot adopt so much of
Done in an unorganized manner, there is no skill or organized team
and the
working.
leakage on joints are also been observed.
But the
Perhaps.
plumbers can be expertise after, say, after a week. This is not a very difficult thing.
This requires 2 to 3 days of training.
Yeah,
Just 2 to 3
within 1
days of
week,
training, sir.
somebody can be expert. This plumber can be expert.
Then this was been provided. Earlier, initially to our training DT can only
And sir, this jointing to be done above the trench.
above the bridge.
Before laying the pipe,
Before laying.
it has to be joined. Somebody will be sitting only, he will be doing the jointing. So in the jointing part, he will be very, very expert. I have seen in many places, in 1 hour for P110 pipes, he can do the jointing of 10 numbers, up to 10 numbers.
That depends again on the size, sir, diameter.
Again, he has mentioned size as well as the PN rating. And depending on the PN rating, the thickness will depend. Because if you use PN6 pipes and PN10 pipes, PN10 pipes of same diameter, the thickness are much higher. So for melting this higher thickness material, it will require more time.
Can you share a light on this? Like if suppose we are having whatever pipe we are getting, we are using, because we are having time to again recheck and retest. Okay. Suppose presume it pipe to be an adult grade pipe. So in that regard, if we obey the standard procedure, will it be okay? If the
Yes,
adulteration is suppose more than 30-35% then?
Yes,
Then also that it will be.
it will be done.
Joint-
Only thing is some factors to be considered. Like he mentioned, if the pipe is oval or lower diameter pipe, there are chances of ovality. Composite,
Ovality has to be corrected.
in case of P63 pipes, ovality का chances ज़्यादा होता है ना?
हाँ होता है.
Because of the low thickness.
But उसमें क्या होता है? For lower thickness pipe, you will not require much number of joints because you will get the pipe in length, 200 meter length.
That is why it is
6
recommended to
meter
join
pieces
with
are
couplers.
also available in the market for 60
सर ओवल्टी इसलिए भी होता है ना कि जैसे कोयल होती है ये जब ट्रक में लोड होता है सब ये दबे और सर यहाँ एक ही चीज है कि यहाँ PN6 मटेरियल है ये अगर PN10 रहता ना सर ना तो कभी बेंड होता ना ओवल्टी होता PN6 का सर थिकनेस बहुत कम है 363 का थिकनेस है बहुत माइनर थिकनेस.
But sir, as your apprehension is still there, as per the standard, even in our laboratory also we have tested, the jointing part, the strength is higher than that of the original pipe. Yes.
Because the bead is diameter, bead is.
Diameter is, yeah.
So obviously.
Provided it
thickness
is
is
joint
much
properly.
joint properly. Provided it is jointing is done properly.
And silicon.
As
What was the joint to
As the same materials are being joined, both are HDPE, the joint is monolithic joint
And it's homogeneous.
and homogeneous joint. So that's why the thickness, ovality, as well as all these factors like the temperature, holding time, pressure, all those things are very, very important. And for a workman, or plumber, he will be expert. Because in many metal fitting or lines, even the illiterate person also become expert on doing the repeating jobs.
They also use PN6 and PE100 different. That's all. You recommend PN6?
PN6 and P100.
Sir, and we have this Android application called Center Go. It is free to use and this is available in Play Store and iStore. Apple iStore. This is for self-training of the plumbers and user who uses the machine.
Probably you have the app also, no?
Yes, this app is there. This app is there. They can self-train and they can select the model of the machine and they can get all the parameters ready. So when they start using the app, with the help of that, they start doing the joints for 2 or 3 days. Then they get expertise. Once after that, everything, then they can get it memorized.
This will be helpful. You share the app, what the app is there.
Definitely.
You just
share you the app link, sir. Share you the app link.
One more question.
Yes, sir.
Do you have any prescribed technology for jointing HDPE pipe to GI pipe? Because in exposed areas, in culverts and all,
Yes, sir.
this happens.
Yes.
It happens in the field. Because in exposed areas and in culverts,
Yes, sir.
our site engineers, they used to put GI pipe.
Okay. Diameter, sir.
Simple.
There are techniques. That is, there is something called stub weld or flange neck. That is welded to the HDPE pipe. That becomes a termination of the
Do
HDPE.
you have pictures, sir?
And from there, I will show you, sir. And from there, you put up mechanical flange and from through the mechanical joint can be made from HDPE to this transition. HDPE to GA transition, HDPE to ductile PA transition. Anything can be done, sir. And even HDPE to PVC transition can be done. Mechanical.
Can you share the
Mechanical joint.
pictures, sir?
Yes, I'll share you, sir. This is not in the slide, but I'll share you the details. I'll show you the details.
আমি আলটিমেটলি কি কৰিছোঁ MS পাইপৰ শ্বু পইণ্ট MS পাইপটো আমি কালাৰটো ফিক্স কৰিছোঁ কৰি শ্বু HDPE পইণ্ট HDPE টো MSৰ ভিতৰত পইণ্ট
Sir, this is older writer.
Sir, and coming back to fusion and there were some doubts about the fusion process and sir, HDPE in India is people think that HDPE in India is just it is a recent technology or recent thing being used in India. HDPE is as old as 50 years in India. HDPE has been used down south in Tamil Nadu, Karnataka, Kerala and all. It has been used even 40-45 years back. It has been used for main pipeline like 630 mm and all. Higher diameters like 630 mm. And there was a project called Mission Bhagirath, Telangana state. They have done 100% and they have achieved 100% of rural water connection, rural water network in India. They have achieved it 2-3 years back. That project was a flagship project of Telangana government. That was a stepping stone in this Jal Jeevan. Before Jal Jeevan itself, they have started this and they had this vision and they have achieved this in Telangana. And for that entirely they use HDPE pipes. HDPE pipes of 1.5 lakh kilometers they have used, and that total worth of the project is 45,000 crores. And not only in water networks, in gas networks HDPE is being used. You have a doubt of the rigidity of the HDPE network. Gas networks use HDPE so that itself conforms the rigidity of the line. Gas is very critical than water. Nobody in India, nobody minds water going out, but gas cannot go out. It's costly also and it's hazardous also. So now HDPE of up to 250 diameter is being used in gas networks for CGD, city gas distribution networks. For every connecting gas to every household. Yes. For CNG and PNG. So this is the various sizes of machines what we have. So we have in perfusion we have facilities starting from 40 mm to 1600 mm in diameter. 1600 in diameter, and we have various variants like automatic and easy life series, basic series, and we have trailer series which is to be which can be used to work in hilly terrains and all, where we cannot carry much equipments. So everything is onboarded into a single setup. The generator, complete machinery setup along with the generator is onboarded into a single setup. Up to 1600 mm diameter we have machineries. And this is a fully tracked machine, fully automatic machine controlled, remotely controlled, and this is 500 diameter, and we have this variant we have up to 2 meters. This machine is being used in Lakshadweep and Andaman Nicobar Islands for desalination projects. Desalination projects for NIOT, National Institute of Ocean Technology. NIOT is carrying out desalination projects in these islands for giving them clean water.
They carried out this project with our material pipe, the pipe made from our HDPE material.
Now there is one more project going on the Agatti Island of Lakshadweep. Sir, is there any doubts in the perfusion process? I hope everyone got the basic terminology and basic understanding of the perfusion process. We will see that through a live demonstration.
I think also if you demonstrate, then it will be clear.
Yes, sir. After this, we will just introduce the terminology and we will have a demonstration. So the next technology for HDPE pipe jointing is electrofusion method, sir. So electrofusion method, as I already told, that for every joint we need a coupler. This coupler has got a coil inside. So there are in the electrofusion joint there are 3 parameters. Those are voltage, resistance of the coil which is used inside. That is the electrical resistance. I mean the electrical resistance of the coil and the time, welding time. This joint takes much lesser time, but the effort is more. Why? Because suppose if we are carrying out a repair joint with perfusion, that takes more time, but the effort is less. But here it takes less time for jointing, making the welding process takes less time, but the effort is more. To insert the coupler, there are no proper technology inserting the coupler. We don't have hydraulic or any system developed for putting it into the pipes. This has to be done manually. Manually, or we have to do hydraulic presses and all. And making a repair joint of higher diameter is very difficult with this one. But fusion is always preferred. So these are the major 3 parameters: voltage, electrical resistance, and time are the major 3 parameters for electrofusion. And we just see a small animation about the electrofusion now. As I told initially, for electrofusion, the pipe has to be prepared. That is, the pipe has to be sprayed, cleaned. Then the pipe coupler has to be inserted and the current has to be passed through the coil, so that the ID of the coupler and OD of the pipe gets heated and melted and it forms a homogeneous joint. So we'll just see a small animation. Yes, cracking it out on the pipe. So just remove the dirt particle or whichever is accumulated on the pipe. And the pipe surface and the coupler ID has to be cleaned with IPA solution. Then it has to be properly aligned. With the help of an aligner, this is the aligning tool. Then the electric terminals are connected across the coupler. In this process, there is a barcode scanner. All this coupler comes with a barcode. So the parameters are embedded in the barcode. You just scan the barcode and the welding automatically starts. So there will be an indicating plug. Once the welding is done, the plug will pop out. This system is mostly used in high-rise buildings and other pressure lines for hot water lines and all.
If you can take air temperature, like its melting is 190.
Yes. Carriage, this part of the system is a mobile carriage. This is connected with hydraulic hoses to the hydraulic system. So this moves forward and reverse. So what we do is before performing the joint, this is the milling cutter, sir. As I already told you, this rotates and during outside this will not operate. Only if we engage into the system. This will operate. Engage into the system, it will operate. This will operate and it will face off the both the ends of the pipes. Like this, the strips will come out. Like this, short strips means this is not yet ready. The strips will come out complete length of the diameter of circumference of the pipe. Suppose if it is both sides it's uniform, then the strips will be long strips. You get long strips. That means the pipe is ready. Once after preparation, we ended for 210 degrees Celsius. You can see it is heated for 210, set for 210. We engage the heating plate in between. We engage the heating plate and we close this. Once we close this, what happens is close this to the specific pressure which is mentioned in the chart. So I'll just show you.
Pressure will be maintained from this.
This system, sir. That is not happening now.
The meter is the piezo, like pressure meter.
We have a gauge over here. You can see here.
Yeah, I've seen.
This gauge has a pressure gauge. And we have a pressure setting and pressure regulating valve. And to open and close, we have a throttle.
How will you adjust the drag pressure?
I'll show you, sir.
Drag pressure.
Drag pressure is measured after making the setup. We slowly adjust the pressure. And at what point of pressure the carriage starts moving with the load of the pipe. That point is called the drag pressure. So I'll explain you. We measure the drag pressure. We make the setting up. Suppose here at field we will be having a long pipe over this end. But usually it is preferred that the new pipe is fixed at this end. That is the movable end. And the fixed end of the pipeline, which is being already existing, is to be set at the stationary end. Existing pipeline is on the stationary end and the new pipe is on the movable end.
Because there is already been laid and
Yes,
fixed.
already laid, yes. So, and also less load applies on this side. We need less pressure to join. So, to measure the drag pressure, after making the setup, we slowly adjust the pressure setting on the hydraulic system. At what point of pressure the carriage starts moving, that is called the drag pressure. So after doing that, after measuring the drag pressure, I'll show you the chart, sir. So we have here the temperature, already we set it on that heating plate. Then we need the bead thickness. Bead thickness we can calculate it from the chart. And we have 110 now, 110 mm pipe. So this is the home screen of the application which I told you. Here ISO 21307 is the standard which is being widely used for pipe jointing globally, not only in India, it is globally. It is an international standard, ISO 21307. And the pipe diameter today we have is 110 mm. And the SDR ratio we have is 21. That is set. Then the drag pressure. We don't have a higher length of pipe, so the drag pressure would be less than 5 bar. So we set 5 bar, and we have a room temperature like it is 28 degree or 30 degree. Then if we start calculating, so we have the parameters in hand. So the heating plate temperature to be set is 250 degree minimum and nominal is 225 degree and the maximum temperature is 235 degree. 235 degree and the bead up pressure, that is a pressure drag plus the welding pressure is 20 bar is required and 1 mm of bead is required. For this pipe only 1 mm of bead is required. Then the heat soak time is 72 seconds. And the total cooling time is 8 minutes 53 seconds. So 72 seconds is somewhere like 1.5 minutes, and this is 9 minutes. So the total welding time would be around 11 to 12 minutes for this pipe.
The drag
Total
pressure,
welding
you have to
time.
give the input of the length of pipe to the drag.
Yes. Yes.
Then it will give a drag pressure.
No. Drag pressure has to be measured at field, sir. So you have to measure. You have to start adjusting the pressure value. At what point of pressure the system starts moving, that is the drag pressure.
Drag pressure.
You have to measure it at field.
Okay.
So
And ultimate pressure that you have calculated.
it's a calculated welding pressure.
Welding
That is welding pressure. The total pressure to be set in the system is drag plus welding pressure. That is the total welding pressure.
When you know this, then you will see the pressure gauge.
Yes,
Then
sir.
it comes to that
Yes.
and fixed with that time, no? Whatever
Yes.
time you need.
Yes, sir. Time has to be, we have to start a stop clock in our say, watch or something, and we have to maintain that. We engage the heating plate, and once after engaging the heating plate, we have to look for the bead size. Once the bead size is achieved, say 1 mm is achieved, we have to reduce the pressure to a value equal to or less than drag pressure. That is in the second phase, P2. Once that T2 time is over, we have to remove the heating plate. Remove the heating plate and engage the pipes together. And set to the initial pressure value, that is drag pressure plus welding pressure. For time T5. Once that is done, our welding will be achieved.
After initial heating, again it has to be made cool, no?
Yes, sir.
Then only it will get for the fusion.
Yes,
Then
yes.
only it will get ready for the fusion.
Yes, yes.
What time need to wait after getting heated, initial heating?
So that is, as per the system, it is 8 minutes 53 seconds. That is 9 minutes for cooling in the system.
First thing you have cleaned.
Ah,
You have cleaned the edges.
yes, sir.
Then drag. The pipe is dragged.
Yes, sir. Right.
Then you have defined the peak size and all.
Yes.
And you
That is 76 seconds initially.
and you put the
76 seconds initially for, yes, we have to wait. Initially it is 76 seconds. After bead formation, we have to wait for 76 seconds. After 76 seconds, we have to remove the heating plate. We have to remove the heating plate and engage the pipes back again together. Immediately. We have to remove the heating plate, that is, we have 6 seconds here. T3 and T4 is there, na? T3 is the blank time, that is 6 seconds. Within 6 seconds, we have to remove the heating plate, and within the next 6 seconds, we have to close it back. We have to engage the pipes back together. So that what happens is the bead becomes thicker. So in time T5, the welding starts. That is cooling under pressure. It's called cooling under pressure.
that time also pressure will be less.
No, higher pressure. You can see that in the graph. The pressure initially, that is a time versus pressure graph, sir. Initially pressure from 0 to P1 plus P2, then drop to P2. Then again we open the system, the pressure becomes 0. Then again immediately we ramp up the pressure, then the pressure goes to the initial value. Then we maintain it for the cooling time. Maintain for the cooling time. After cooling time we remove it, then the joint will form.
When the fusion has already occurred,
Yes, sir.
then why you are again increasing the pressure? Like it's a
That is the actual. No, cooling has to be done under pressure. Cooling under pressure. That is the actual. Sir, out of these 5 phases, phase 5, that is the 5th phase, is the actual welding phase. That is the actual welding phase. During that, welding happens. During that phase, welding will happen.
only the hot plate is not there,
Yes, yes.
but the thing will be occurred
Yes.
at that time.
So the thing is recorded at the both end or only in one end?
Sorry, sir.
The thing is recorded the both phase or only in one?
Both the phase, sir. Heating is required on the both the phase. Both the phase. When we close, both the phases will get heated up.
But both will expand.
Sorry?
The boat is there, boat will be expanded. One is to put.
Not to the other. One is one part going to the other, right?
Not going in, just butts, sir. Butts against the face. Sir, I said, sir. Just like this. So, but it will just but. That's why it's called butt fusion, sir. Just butts together and gets a fusion. That becomes like a single pipe. Single pipe of the same diameter. This is 1 meter. This is 1 meter and this is 1 meter. So when we join, this becomes a single pipe of 2 meter.
The bead, which you are talking about, bead. Which is the person in the bead?
Sorry, sir.
Can you know which is the person? Bead person.
The heating area.
Heating area. What happens is after heating, what happens is
It is one.
after heating, this space gets heated, sir. This space is also will get heated. Once we join, what happens is once we join, this face and this face will tend to roll out. Since it is flexible and it's plastic, thermoplastic. What will happen is under pressure this will roll outside on both the sides. That rolling out is called bead. That forms when we join with temperature. That forms on both OD and ID also. Both this outer this area and this area will tend to roll out. Sure the face is smooth. Since it gets inside the coupler and gets stopped, there is a stopper inside. Both the faces get stopped inside. So to get a proper stoppage, we need the faces to be uniform and parallel. We have to ensure that. Then after ensuring that, we need to know the depth to which the pipe is getting inserted. So once we measure that, we have to make a marking, and after make a marking, we need to scrape to that depth. This is the scraping tool. This is just to remove the oxidized layer. Since HDPE pipes are not stored in a closed environment, it's usually stored in the yards, outdoor yards, and also dirt particles gets accumulated on this. So to remove that dirt and moisture, we are just cleaning it with the help of scraper. A thin layer of 0.2 mm. 0.2 mm is prescribed in the standard. 0.2, that is 200 microns, has to be removed. This process has to be followed for the other end of the pipe also, other pipe also. once after scraping, we should clean it with isopropyl alcohol during it is being welded in the service line. IPA, isopropyl is IPA. Inserted. I will just show you row by row. So you can see this is the barcode, sir. You can see this is the barcode. The barcode has the fusion time clearly mentioned. This is 65 seconds and the cooling time is 7 minutes. So the total time will is taken is 7 minutes 65 seconds. This parameter is embedded inside the barcode. Once we scan with our barcode scanner, this will get entered into the system automatically. So every electrofusion joint will have this parameter embedded inside that. And we have something called an indicative plug. These two are called indicative plug. Once the welding is over, this will pop out. That is the indication that the welding has happened successfully. I'll just show you row by row. You cannot see that. You can see that. This is the indicator plug and this is the barcode embedded from the manufacturer. Here it is. This is the barcode and this is the barcode. Once we scan, automatically this gets set into the system.
reducing socket joint to
Here is the indicator plug.
same diameter pipe, same diameter pipe, into reducing socket joint. Voy a property as you Excuse me.
Crosses are there, X joints are there. This parameter is embedded into the barcode. Once you lead to leakage, definitely it will. Okay. Now that saddle is also mostly widely used as electrofusion saddles. Right. Are worried about leakages, joint issues and all. The more emphasis has to be more on the parameters, sir. Since these contractors, they know the parameters, they are expert in parameters, but they don't follow because they skip the cooling time. Cooling time is very critical for both the joints. Now it has joint and we have to allow it for 7-8 minutes. We have to allow it freely so that the joint forms. Because during the cooling time, what happens is this free molecules will set up so that the joint happens properly. So this cooling time is not allowed properly by the contractors to save time, basically to save time, to make more number of joints. That has to be ensured, sir. And this pressure, emphasis has to be on the pressure and temperature. Pressure, they don't use the right pressure. They might know the parameter for 110 dia and they use the same parameters for 160 also. So that will not work out. So the parameters is different for every diameter and every thickness. So they have to ensure the right parameters are being used. This has to be crossed on day-to-day or some data or logging system has to be there manually with the